In this lesson, we will learn about isotopes and isobars. Now, isotopes are atoms of elements having same atomic number but different mass number. Let us take the example of isotopes of hydrogen. Hydrogen has got three isotopes. One is hydrogen with the mass 1, atomic number 1, and that's called protium. Then you have hydrogen with the mass 2, atomic number 1, and that is called deuterium. Hydrogen with atomic number 1, mass 3, and that is called tritium. Now, if you see in this three isotopes, the atomic number is the same. Here you have atomic number 1, atomic number 1, atomic number 1. All of them have the same atomic number. So there's atomic number 1, atomic number 1, atomic number 1. Now for the mass number, so the mass number in this case is 1, here it is 2, and here it is 3. So different mass numbers, 2 and 3. And you know mass is protons plus neutrons. Let's see the subatomic particles. Let us see how many protons, how many electrons, and how many neutrons. Now we know the protons is atomic number. So atomic number is number of protons. So all of them have the same number of protons, and that is 1. So here 1, here number of protons 1, number of protons 1. And number of protons equal to number of electrons. So number of electrons 1, number of electron 1, 1. Now to find the number of neutrons, we use the formula. We know mass equal to protons plus neutrons. And in the first case, we see the mass is 1. Here mass is 1 and proton is 1. Proton is 1, so we have neutron. So neutron will be 1 minus 1, and that is 0. So you'll have 0 neutrons. Now for the second case, again mass is protons plus neutrons. So in this case mass is 2 and protons is 1. So we put mass 2, protons 1. So the neutrons is 2 minus 1, and that is 1. So in the second case the neutrons are 2. And in the end we have again mass equal to protons plus neutrons. Then the third case the mass is 3. Protons is 1. Neutrons. So neutrons equal to 3 minus 1, and that is 2. So here this was 1, and here the neutrons are 2. So when you take the first isotope, that is protium, and you see the electronic configuration is 1. The second isotope, it has got 1, atomic number is 1, so configuration is 1. And tritium, 1, electronic configuration is 1. So in the K shell, all of them have got 1 electron each, and so the number of valence electrons is same. And since the number of valence electrons is same, they have similar chemical properties. They have in fact same chemical properties. So all isotopes have same chemical properties because they have the same electronic configuration and the number of valence electrons is the same. We'll now take isotopes of chlorine. Chlorine has got two isotopes. Both will have same atomic number, but the mass number is different. One has got mass number 35, the other has mass number 37. So when we go to atomic number, will be 17 and 17. Atomic number 17 and 17. Same atomic number, mass number. Here it's 35 and this is 37. So that will be 35 and 37. Now for subatomic particles, let's see how many protons, how many electrons, and how many neutrons. Now protons is atomic number. So in this case protons is 17. If 17 protons, 17 electrons, because number of protons equal to number of electrons. Here also 17 protons, so 17 electrons. Now to find the neutrons, we use the formula mass equal to protons plus neutrons. In the first case, mass is 35 and protons is 17. So we have 35 equal to 17 plus neutrons. Neutrons is, this is 35. So this is 35 minus 17, which is 18 equal to neutrons. So here the neutrons are 18. Next again, for the next, mass equal to protons plus neutrons. Proton 37, mass is 37, protons is 17. So we have 37 equal to 17 plus neutrons. So neutrons is 37 minus 17, so 20 is neutrons. Now let's look up at the electronic configuration. For chlorine, atomic number is 7. Remember, for electronic configuration, atomic number is important because that gives us number of protons and that gives us electrons too. So electronic configuration is 287. For 17, say 37, and this is 35, we will take 17 and that also will be 287. And so the number of valence electrons is the same. Both of them have same number of valence electrons. And since the number of valence electrons is same, they have same chemical properties. So again, isotopes have similar or same chemical properties because the electronic configuration is the same. The atomic number is the same. Now we'll go to isotopes of carbon. It has got two isotopes, atomic number 12. In both the case, atomic number is same. But here mass number is 14 and here mass number is 12. So for atomic number, so the atomic number here is 12. The atomic number of carbon is 6, not 12. So here it is 6 and here also 6. So atomic number is same, that's why it is isotope. Now for mass, 14 and here 12. So here you have 14 and this is 12. Number of protons equal to atomic number. This is number of protons. So this would be 6 and 6. The electrons are equal to protons. So if protons are 6, electrons are 6. Protons 6, electrons 6. Now to find neutrons, we know mass is protons plus neutrons. So we have mass equal to protons plus neutrons. Now the mass is given as 14 and the protons are 6. So 14 equal to 6 plus neutrons. Neutron equal to 14 minus 6. So 8 neutrons. So here we have 8 neutrons. In the next case again, mass equal to protons plus neutrons. The mass is 12 and the number is 6. So we have mass 12, number 6 plus neutrons. Neutrons would be 12 minus 6 and that is 6. So here neutrons is 6. Now let's go and see what is the electronic configuration. So we have carbon 6 and 14. To write the electronic configuration, we always use the atomic number, never the mass. So atomic number is 6, so it is 2 and 4. Now for carbon 6 and 12, to write electronic configuration, you take atomic number. So atomic number here is also 6, so 2 and 4. So if you see for both these, the valence electrons is equal to, for both of them, the outermost electrons, or called the valence electrons, is 4. Same valence electrons, so same chemical properties. So isotopes have similar chemical properties because the atomic number is same and electronic configuration is also same. Now isobars. Isobars are atoms of different elements with different atomic numbers but same mass number. So let's write that again. So we have isobars. They have same atomic number. Not same mass number. Same mass number. That means protons plus neutrons is the same, but different atomic number. Number of protons is different. The examples of isobars are like we have calcium, which is calcium is written as Ca, and atomic number 20, mass is 40, and argon, which is Ar, and atomic number is same 40, but the mass is 18. So let me just write this. So for calcium, just write the atomic number. So in this case, atomic number is 20, and here it is 18. So we see the atomic number is different. So it is 20 here and 18. But the mass number 40, and here also 40. So mass number is 40 and 40. Will they have the same chemical properties? So let's write the electronic configuration. So now we have calcium, which is 40 and 20. Now remember, for electronic configuration, what is important is the atomic number. So atomic number is 20, which means it will be 8. No, first is 2, 2, 8, 8, 2. And when it comes to argon, 40 and 18. So I have 2, 8, 8. Now look up at the valence electrons. The valence electron will decide if it has got similar properties or not. So here the valence electron, the outermost electrons is 8, and outermost electron 2, and here outermost electron is 8. So number of valence electron is different. And if the valence electrons are different, they have different chemical properties. So remember that isobars have different chemical properties. So we'll now write the difference between isotopes and isobars. So when it comes to atomic number, they have same atomic number. And isotopes have different atomic number. Next, let's see its mass number. So here they have, so when it comes to mass number, isotopes have different mass number. And isobars have same mass number. Now for chemical properties, since isotopes have same atomic number, they have same chemical properties. And since isobars have different atomic number, they have different chemical properties. Now, example of isotopes, we have hydrogen, which has got 3 isotopes. Then we had chlorine. See, the number is the same, the mass is different. We have carbon, same number, mass different. And isobars, calcium and argon, the mass is the same, but the number is different. If the bromine atom is available in the form of, say, two isotopes, bromine 79 and the bromine 81, calculate the average atomic mass of bromine atom. So we have two kinds of bromine atoms. One is bromine 79, the number is 35, and the percentage of this is 49.7%. And we have another bromine which is also 35, because isotopes, the number is the same, but the mass is different, is 81, and this is 50.3%. We have to find the average mass. So for this is quite simple. We just do here 49.7% of 79 plus 50.3% of 81. So 49.7% means over 100 into 79 plus 50.3% of 81. When you do this calculation, you get 3926.3 over 100 plus 4074.3 over 100. Add this up, you get 8000.6 over 100, and that is 80.006. U will be the average atomic mass of bromine, of the isotopes of bromine. If the average atomic mass of a sample of an element X is 16.2, what are the percentage of the isotopes X16 and X8? So we'll say let the percentage of X16.8 be X%. If this is X%, then the other isotope will definitely be 100 minus X%. Because see, if you have 100%, if 1 is X%, what remains is 100 minus X. So the percentage of the X18.8 will be 100 minus 9%. Now when we calculate this, we'll have X% of here 16 plus 100 minus X% of here 18 equal to the average, which is 16.2. So we work this out. X% of 16 plus 100 minus X% of 18 equal to 16.2. So 16x over 100 plus we do 18 into over 100 equal to 16.2. Now the LCM here is 100. So 16x, open the bracket, and this is 18x equal to 16.2. So let's go ahead. So 16x minus 18x is minus 2x minus 1800 equal to The 100 I take on the other side, 16.2 into 100. So minus 2x minus 1800 equal to 1620. So minus 2x, this is here, this should be plus. This is 1620 minus 1800. So minus 2x equal to minus 180. So x is minus 180 over minus 2. So x is 90. So that means the isotope, the first isotope which we had taken is 16N8, the percentage of that is 90%. And the other isotope, which was X18, will be 900 minus X, which is 100 minus 90, and that would be 10%.